polygon scan fill algorithm. Okay, right? So that means what we had left out in the second module, right? So we saw there is we discussed about many things on polygon, fine, right? So we discussed about types of polygon: convex polygon, concave polygon, fine. We discussed about how to identify a concave polygon, fine. Next we discussed about if my polygon is concave, how to divide that into convex polygon, right? So once we discussed on how to divide that into convex polygon, right? So we also discussed, okay, right? Finally, we have converted any type of polygon into convex polygon. So once the required type of polygon is there, right? How my computer will identify the interior pixel and exterior pixel inside my polygon, right? So in the interior pixel and exterior pixel of my polygon, right? Once it identifies the interior pixel and exterior pixel of the polygon, fine. So next thing is I need to fill that interior side of the polygon with the required color. Okay, right? So now whenever we thought of filling it with the required color, right, we also saw that whenever I need to fill any object with the color, I cannot just randomly fill that with whatever color that we feel. Fine. We need to fill the color in some systematic manner, right? That means we need to fill the color in a horizontal manner, or we need to fill the color in a vertical manner, or we need to fill the color in some diagonal manner so that it looks good. Okay, right? So now, so we are in that particular step where we need to we need to fill the polygon with the color. Okay, right? So now consider, fine. So my polygon is this. Consider I have my polygon. Consider this is my polygon. Okay, right? Now I need to fill this polygon with the color. Okay, now fine, right? So now, yes, whenever I talk about raster display devices, fine. So in the first module we have discussed about random and raster methods, right? So whenever we discuss about that raster methods, fine, right? So we also know that, right? So any display device, right, we will be having the scan lines. Sorry, straight lines it should be, right? So scan lines, fine. So these are the scan lines. Okay, these are the scan lines, right? And I have my object, right? That is which is in the rhombus shape, right? Which I need to fill the color. Fine, right? So now how I have drawn this scan line is, right? I have drawn this scan line based on bottom top approach. Okay, right? That means from the bottom I've gone drawing the scan lines, right? Actually the scan lines will not be this much far away how I have drawn, right? Actually the scan lines will be very close to one another. Okay, right? It will be very close to one another so that if I so that it looks like it is filled. Okay, right? So it will not be far away like this, right? It will be very close to one another. So for explanation purpose I have made the thing like this. Okay, right? So now these are my scan lines, right? And this is my polygon that needs to be filled, right? And whenever I say I have drawn the scan lines based on the bottom up approach, that means, right, my scan lines are my I have drawn the scan lines based on y axis, right? So that means this is y is equal to 0. Okay, right? This is the scan line, right? This is y is equal to 1. Okay, next this is y is equal to 2, right? So this is how I have gone drawing the scan lines. Fine, right? So now, yes, right? So I have my scan lines, right? And also I have my polygon here. Fine, right? So now I have also seen that, right? So whenever I have any convex polygon, right? So whenever I take any two, 1 minute. whenever I have a convex polygon, and whenever I take any 2 points, right? So in that convex polygon, right, and I draw a line between the convex polygon, the entire line will be inside the polygon only. That is what we have learnt in convex polygon. Correct, huh? Right? So whenever we take 2 points and whenever we draw a line between those 2 points, right, the entire line will be inside the polygon only, right? So now my question here is, right, kindly observe what I am asking, right? Kindly think on the lines what I am asking. Fine. So now if I say, fine, right? So 1 minute, let me erase this. Okay, right? So now what is my question is, right? So if the concept is this, right, where I say that in my convex polygon, if I consider any 2 points, the line joining those 2 points also lies inside the polygon, right? That means if I take any 2 points and if I draw the line between those 2 points, means, right, that much coloring is over, right? See, now if I take these are the 2 points and if I draw a line between these 2 points, means, right, if I draw a line like this, that means this much amount of coloring of my polygon is over. Fine, right? So if this is my concept, right, now I what I want is, right, so in my existing polygon, that means in my this polygon, right, so which will be the best 2 points, okay, that I should go on considering, such that I can fill my polygon easily. Right, getting my question? See, what I am asking is, right, so if my concept is, if I consider any 2 points and if I fill between those 2 points, right, so the entire fill will be within the polygon only, and the filling of that particular region will be completed. Correct, right? So now keeping that in mind, right, so in my this polygon, right, what will be the good selection of points, right, so that if I connect those points, right, so my polygon filling, a particular part of my polygon filling will be completed, right? What set of points I should go on selecting in this polygon intelligently?
Corner points, sir. Border points.
Okay, fine, right? So yes, right. See, let me explain this with some simplicity. Fine, so that it will be understandable for everyone. Fine. So now let's consider, right? So if this is my polygon, right, and if I choose 1 point here and 1 point here, and if I fill this with this, right? Okay, this much has been filled. Now for the remaining part, this much part and this much part, right, again I need to select 1 point here, again I need to select 1 point here, and I need to again again I need to draw a line between that, so that this part gets filled. And for again this below part, again I need to select 1 point, again I need to select 1 point, and I need to cover this fill these points, so that entire line gets completed, right? So now that means selecting the 2 points randomly does not work for me. It works for me, but it is not an efficient method, right? So time complexity, whenever I go for time complexity, it takes more time to fill the polygon, correct? If I select any points randomly, right? So my selecting the points should be in an intelligent manner, such that the work should be less, right? That means within a minimum amount of time with the less work, right, I should complete filling my polygon, right? In such cases, how I should select the polygon? I should select the polygon, I should select the points, right, such that it will be in the borders. Okay, right? If I select borders like this, okay, if I join that, okay, anyway I know whenever I take any 2 points on the convex polygon and I join that, obviously it will be inside the polygon only, right? So when I take these the 2 points on the corners, and I connect that with the line, right, obviously this line will be inside the polygon, and this part of this polygon has been filled with the color. Correct, right? In such case, right, how I have to select my points, right? My intersection, I have to select the points like this, right, such that it will be at the borders and on the scan lines, right? So my points are will should be the right the intersection points between the polygon edges and the scan lines. Okay, this is how I should go on selecting the points, intersection points. Okay, right? So I should go on selecting, I should go on considering the intersection points, right? So once I consider the intersection points, right? See, what is the first thing that I need to do for filling the polygon, right? So the first thing that I need to do for filling the polygon is to consider the intersection points. Okay, right? So first thing is to, I need to select the intersection points. Okay, select the intersection points. Fine, right? Select the intersection point, right? So second step is, right, once I select the intersection points, right, so what I need to do, I should go on finding all the intermediate points between these two selected intersection points, right? And that is how it fills the polygon with the required color, right? So next thing is, right, so once I select the intersection points, I need to go on selecting the next, I should go on finding the next pixels. Okay, right? So next pixels, finding the next pixels is not a big issue, right? Because if I say, right, so if this is one point and if this is the another point, right, so how do I select the next pixel, right? So next pixel means, right, so it is horizontal movement. It is horizontal movement andre, right, what I will be doing from the first pixel. Okay, from this first pixel, right, I will increment x value. I will go on incrementing x value so that I will be getting the next pixels. Okay, right? So once I get the two border points, that is intersection points, right? So finding the next pixels between that intersection points which forms a line for me, right, that is not a big issue. It is just by incrementing the value of x, right, I will be getting that. Okay, right? So this is not a very big issue. Fine. Once I find all the intersect, all the between points, between the intersection points, next thing is I will fill them with the color. Okay, I will fill them with the color, right? So filling the color is also is also not a very big task, right? So if I give GL color 3F and if I specify what is the color, obviously that color I will get and I will fill that, and I will fill all the points with the rest with that particular color, right? So now these two steps are not that much difficult for me. Okay, right, getting the next points once my intersection points I got, once I get my intersection point, getting all the in between points are not a big task for me, because it is just by incrementing the value of x, because it is moving horizontally. So I will increment the value of x and I will get all the intermediate points. Fine. And once I get all the intermediate points, right, filling that intermediate points with the required color, that is also not a big task. It is just a matter of a function, GL color 3F. What is the difficult task for me, or the challenging task for me, is to this first step, that is selecting the intersection points, right? So my computer, it is not me, it is not the user, my computer should efficiently select the intersection points, right? Intersection point between the edge of the polygon and the scan line. Okay, now this is the challenging task for my computer. See, we have vision, we have intelligence, right? And as soon as I see this diagram, okay, I can clearly, I have marked which is the intersection point between my scan line and this, okay, my polygon edge. But my computer doesn't has any vision, my computer doesn't has any intelligence, right? Now how to make my computer select this intersection point is the question. Okay, right? And this is what we will give importance in this particular process. Okay, these two are easy for me, right? I will not scratch my head too much on these two steps. On which step I will concentrate more is the selecting the intersection points. Okay, right? Because my computer doesn't has any vision and my computer doesn't has any intelligence, right? So selecting these intersection points always becomes difficult for my computer, right? And for that they came up with an algorithm, right? That algorithm is called as scan fill algorithm. Okay, scan fill algorithm. Fine, that algorithm is called as scan fill algorithm. Okay, fine, right? So now, yes, this is what the process is. That okay, this is what the process. So let me see the general idea of the process and everything, right? What they have explained, and then we shall come to the phase where I will tell how your computer will find the intersection between the edges and the scan lines. Okay, right? So that it can fill the intersection points, right? And that particular part of the polygon will be colored successfully. Okay, first we shall read the outline, right? This is what the outline is. Okay, right? So first I will find the intersection points between the scan line and the polygon edges. Then I will find all the pixel in between the two intersection points, right? So and then I will color those complete points, right? So that that particular line in my polygon will be filled with the required color. Okay, na, right? So I want you people to keep in mind that, right, always we go with the bottom up approach. Okay, whenever I say I'm going with the bottom up approach, right, so you should remember that I'm going with respect to y axis. Okay, right, y axis. At y is equal to 0 1 scan line, at y is equal to 1 1 scan line, at y is equal to 2 next scan line, next at y is equal to 3 another scan line. It goes on like this. Okay, right? So keep this in mind and let us see what they have discussed here. Okay, right? So general polygon scanline fill algorithm. Okay, right? So a scanline fill of a region is performed by first determining the intersection positions of boundaries of the filled region with the screen scan line. Alva, right? So this is my scan line, right? What is the first thing that we do? We will find the intersection position of the boundaries. We'll find the intersection position of the boundaries with the screen scan lines, right? So that means first what we will be doing, right? So we will be finding the intersection position. That means this position, this position. Okay, this position, this position. Fine, right? So then the fill colors are applied to each selection of the scan lines that lies within the interior of the filled region. That means I will apply the fill colors, right, to all the interior regions between the two intersection points, right? So that is fine. Okay, let me go to this general steps, right? So now first find the number of scan lines, right? So number of scan lines means here for example I showed only one scan line. There will be n number of scan lines. Sorry, right? There will be n number of straight lines. Okay, straight scan lines. Fine, such that it looks like a completely filled polygon. Okay, right, completely with a very short distance, right? You will get the scan lines, right? So that if I go on viewing that scan line, it looks like right the polygon is filled. Okay, right? So first I will find the number of scan lines. Fine. Then for each scan line, what I will do is, right, for each scan line, that means if I consider this black scan line which is there, what we will do is, right, we will obtain the intersection points of the scan line with the polygon edges. Okay, which are the intersection points with the of the polygon with my scan lines, right? So it is 10 at x, correct? Right. Next 14 at x. Okay, next 18 at x, next 24 at x, right? So these are my what is 14 10 24, however your computer selects. Okay, right, it is not that your computer always selects it will go in a particular order and it will select, right? It will just collect the intersection points first, right? So it may be random. Okay. Once it collects the intersection points, right? So the next thing is it will sort the intersection points from left to right. Okay, that is ascending order. Fine. Once it sorts all the intersection points, then it will pair the intersection points. That is first two, and it will go on pairing based on sequentially, right? Pairing andre first second na pair ಮಾಡುತ್ತೆ, third fourth na pair ಮಾಡುತ್ತೆ, fifth sixth na pair ಮಾಡುತ್ತೆ, seventh eighth na pair ಮಾಡುತ್ತೆ. It goes on pairing like this. Fine. So here we have only 4 points, so two pairs we will get, right? So which are the two pairs? 10 and 14, first 2 points, and next 2 points are the another pair, right? So now once I pair, right, so what is the next thing is I will find all the pixels within that pair, right? All the pixels within that pair means within 10 and 14, right? Between 10 and 14, which are all the other pixels? It is 11, it is 12, it is 13, it, that is 11, 12, 13. Fine. On the same lines between 18 and 24. Okay. 18, 19, 20, 21, 22, 23. It goes on finding all the pixels between the pairs, right? And it will that is how it finds, right? And it will fill that with the color, right? And this continues for all the scan lines, right? For this scan line I have shown on the same scan line on the same basis, right? Next it will goes to the next scan line, next. This is what it does, and it will fill all the intersection points, and I will get the color. Okay, na, right? So now my question is, right? So whenever I find the intersection points, okay, right? So do you feel that always your intersection points will be even number? Because if you get even number of intersection points, then only you can pair those intersection points. Correct, Allah, right? So what is the next step after finding your intersection points? Once you find the intersection points, so the next thing is you need to pair those intersection points. So you need to pair those intersection points in Andre, right? So obviously you should have even number of intersection points. Correct? Right? Do you feel that always you will get even number of intersection points to pair it? To pair it straightforwardly? Definitely not. See here. Consider this y dash scan line. Right? So now see how many intersection points are there. This is the first intersection point. Okay. This is the first intersection point. This is the second intersection point, and this is the third intersection point. See here only 3 intersection points are there. That means odd number of intersection points. Fine. Now how it will pair, right? So now it's completely it's completely difficult task, right? Fine. So now for this they come up with a new idea that whenever I find a intersection point, okay, right? So which is connected by two edges, okay, right? Whenever I find intersection points which is connected by two edges, okay, right? See, this is see this two this second intersection point is the one which has connection to two edges, right? And whenever the two edges that are connected to the intersection points are in a different direction, correct? These two are not in a straight line. For example, if it is like this, and if your intersection point is somewhere here, okay, both are in the same direction, right? So now that is not the case here, right? So what is your case? One is like this, one is like this, and this is your intersection point. That means, right, both are in the different direction, right? Whenever I find the intersection point, okay, between the two edges, right, and those two edges are in the different directions, right, then I will split this intersection point, right? So now how my intersection point looks is 1 comma 2 first set, right? So and second set will be, I have said I will split it, right? So my second set will be 2 comma 1. Okay, that is first set will be this, okay, second set will be this. Fine. So now I got two pairs, right? Keep this in mind whenever in you have a problem for this, which we will see now, right? So whenever we get an intersection point, right, such that both the edges are moving in different directions, right? So what we will do, we will split that intersection points into two, and I will make the two, I will make the pairs. Okay, right? So now consider this scan line y. Okay, here also I have an intersection point where I have two edges, right? But see the edges are moving in a straight line, correct? That means, right, whenever I find that the edges connected to intersection point are moving in a straight line, I consider the intersection point only once, right? That means 1 2 will make one pair, right? So and this 1 1 will make another pair, right? So these are the things that I need to explain here, right? Always intersection points will not be even numbers, right? So if you find any intersection points like this, okay, where you have you have an intersection point which has two edges pointing to different sides, then you should split that intersection point into two. Okay, whenever you find the intersection point where it is moving on a single line, okay, right? So you will consider that intersection point as only one intersection point. Okay, na? Right? So now once we have discussed this, right, so let me come back to the process, right? What to do next? Okay, right? So now consider, this is my polygon. See, I have changed my polygon. I have changed it to triangle because this is the example that we will look into next. Adike, right? So now, whenever I say about scan line, this will be the first scan line. Okay, right? So for just for a explanation purpose, I am taking the scan lines very far from one another. This will be the next scan line. This may be the next scan line. Okay, now, right? So, and I also said the scan line will be based on y axis, that is up down moment ಅಂದ್ರೆ y moment. So here y will be equal to 0. Okay, right? So now here y will be equal to 1. Okay, and it goes on like that. Y is equal to 2, and it goes on like this, right? So now what is the what is the method or technique that I said to fill the uh, that is to fill this scan line, right? To fill this polygon, the technique what I said was, right, I will find the intersection point between the scan line and my polygon edge. Okay, this is the intersection between my scan line and my polygon edge, right? Once I find the intersection between my scan line and polygon edge, right, I will find all the intermediate scan lines, okay, which will be very near to one another, right? So I'll find all the intermediate pixels, and I will color all this pixel with the required color, right? How do I find all the intermediate points? It is by incrementing x by 1. So I will get all the next pixels between the intersection points. Fine. So next thing what I will do, this is the next intersection point. Okay, right? So now I will find these two intersection points. Fine. So next I will fill the intersection. I will find all the intermediate pixel between this intersection point, and I will fill that with the required color. Fine. So I also said second and third step is easy. Finding the intermediate points between the intersection points. Okay, intermediate points between those intersection points, just incrementing x by 1, I will find all the intermediate points, and I will fill that with a color by using a function glcolor3f. What is the difficulty for my computer here is, right? So how to find these intersection points? Okay, right? How to find this intersection point? Okay, right? So let me explain you how my computer will find this intersection points, right? So it obviously it always starts from it always starts from that is bottom up approach. Okay, kindly remember this. It always starts from bottom up approach, right? So if my axis is like this, okay, if my axis is like this, right? So now this intersection point, what is the value of this intersection point?
0.
It is 0 comma 0, correct? This intersection point is 0 comma 0, and this intersection point, right, what obviously y is 0, y is 0 tane, y is 0, right? So x, whenever I consider x it may have moved by some units. I will call this movement as 6 units, right? So this intersection point will be 6 comma 0, right? So this intersection point is 0 comma 0, this intersection point is 6 comma 0, right? So next, what is the next thing that it does in next step, right? It goes on finding the next pixels. What will be the next pixels? It will be 1 comma 0. Okay, so next one will be 2 comma 0, right? So next thing will be 3 comma 0. Okay, right? So next one will be 4 comma 0. Fine. So next one will be 5 comma 0. Fine. And the next I have 6 comma 0. So yes, this was the second step, right, where I will find all the next pixels, right, and I will color these pixels. Fine. First scan line is over, right? Now come to the second scan line, right? So what will be the value of this particular intersection point? What will be the value of this particular intersection point now? What will be the value of this intersection point? At least you can guess what is the y value at this two intersection point.
1.
Correct, right? So because it is based on, I have clearly said, that was what that was why I was saying this, right? It is always bottom up approach. Okay, right? It is always bottom up approach in the sense, right? I'm considering y values. Okay, my scan lines, right, is based on my y value. That is, first scan line is at y is equal to 0, my second scan line is at y is equal to 1, my third scan line is at y is equal to 2. That means if for this intersection point, my y values will be 1. Okay, my y values will always be 1. Agree with this? I think everyone agrees with this. Fine. My y value will always be 1, right? So now the difficulty is, what is the x value? I need to find the x value, right? So the intersection points x values, right, to find, because it's not the only one intersection point. It will be having thousands of intersection points. Okay, right? For all those intersection points, y value I can get, but x value, it is difficult for me. It is not that so easy to find, right? So now all the x values of the intersection points, we can find it out by a method called as coherence property. Okay, right? So they call it as coherence property. Right? What this coherence property tells is, okay, right, what this coherence property tells is, fine, if I know xk, okay, if I know xk, right, so I can find the next x value, that is xk plus 1. This is what coherence property tells. Okay, if I know the previous x value, I can go on finding the next x values. Next x value, not x values, it is next x value. One succeeding x value, one immediate next x value, I can find it out, right? So going with respect to this particular property, anyway I know this x value, is 0, right? And here the x value is 6, right? So if I know these two x values, obviously that means, right, I can know the x value of these two intersection points. Okay, right? So how means, right, what is the equation that they give you is, right, so xk plus 1, that is the next x value is nothing but the previous x value. Okay, see, these are the different mathematical research that they have done. Okay, right? So just we are concentrating on the end result of that research. Okay, na, right? So that the next x value, xk plus 1, is equal to xk, that is previous x value, plus 1 divided by slope. Okay, 1 divided by slope means, right? So for this particular x value, this is my slope, these two, this is the slope. Okay, this is the side that I need to take for this x value, right? This is the side that I need to take for slope. Okay, na, right? So that means, so this m, what this m says, you know that, right? It is dy by dx, correct? Right? So this is dy by dx. Okay, right? So now this is xk plus 1 is equal to xk plus okay, 1 divided by dy by dx andre, that simply means, okay, xk plus 1 is equal to xk plus, okay, what happens, this the denominator of the denominator comes to numerator, correct alva, right? So xk plus dx by dy. Okay, this is how I will find the next x values. Okay, kindly keep this in mind, right? So intersection points, finding the intersection points is a very important task for me, right? So how do I find the intersection points? Yes, y value, finding the y intersection point is not difficult one for me. Y intersection point is nothing but the value of that particular scan line. Okay, finding x intersection point is difficult task for me, where they have stated a property of coherence by which they are telling that, right, if you have previous x value, right, I can get the next x value by this equation, where new x value is equal to xk, that is previous x value, plus 1 divided by m, that is dy by dx. So that means that becomes xk plus dx by dy, right? So whenever this we will solve a problem for this, right? So whenever we solve a problem for this, kindly remember that, okay, y value, it is just increment. Okay, right? So if the previous y value is 0, next y value or next y value becomes one more than the previous y value, which is the value of your scan line, right? But when you come for your x value, right, so how you will find new x value? It is previous x value plus 1 divided by m. This is how you will find your next x value, right? So I will store this value of m, okay, I'm sorry, I will store this value of 1 by m, right, to some place, right, so that each time when I need to calculate the next x value, I can take the previous x value, because I would have already found it out, right, plus I will take 1 divided by m, so that I will get next x value. Okay, na, is this clear, right? This is how your computer will find the intersection points, right? So fine, let me go to the issues. That is what they have said everything here, right? See, this is if these two are the scan lines, if this is xk yk and this is xk plus 1 yk plus 1, fine. So how this is this yk plus 1 is nothing but it is yk plus 1, no doubt, right? But what is xk plus 1? Xk plus 1 is always xk plus 1 divided by m. Okay, right? So what, that is nothing but xk plus 1 is equal to xk plus dx by dy. Actually xk plus 1 divided by dy by dx, so the denominator of the denominator goes to numerator. By that property, xk plus 1 is equal to xk plus delta x by delta y. Fine. So now whenever I go on getting, the first thing what my computer does is, right, it goes on getting all the intersection points. Okay, once it gets all the intersection points, then it will start finding the intermediate points between the two parallel intersection points and coloring, right? So what is the first thing my computer will do? It will first get all the intersection points, right? So whenever it starts calculating and whenever it starts getting all the intersection points, right, I need something to store all those points, right? That means I need some data structure to source, I need some data structure to store those intersection points, right? If I just calculate and leave it, right, obviously that will be lost. So I need some data structure to store all those intersection points, right? So that particular data structure is called as sorted edge table or active edge table, right, which contains all the informations necessary to process the scan lines efficiently, right? So that means it contains all the intersection points that it has calculated, right? So that it helps us to further process. Okay, now, right? So this is the complete concept of your scan line. Okay, how this how polygon filling will happen, right? So now let us look at the table, right? Let us look at the problem, right? So what let us look at the problem in the sense what they will be asking you in the problem is, right? They will not ask you to find all the intermediate points between the two intersection points and coloring. That is done. Okay, that is not a big issue at all, right? What they will be asking you is they will be asking you to find the intersection points, all the intersection points in the given polygon. Okay, that is what they will be asking you. Okay, fine, right? So that is what they will be concentrating, and that is what they will be asking you in the examination. Fine, right? So let me come to the problem, right? The problem is this, right? Determine the contents, all the contents of active edge table, right? Active edge table, right? Or sorted edge table. What your sorted edge table contains, as I have said, your sorted edge table contains all the intersection points, okay, that it has calculated, right? So that is what I need to find it now, right? Calculating the next things are simple, okay, right? That is next pixels between the intersection points is simple, but what is the main thing is I need to find the contents of active edge table, okay, right? To fill the polygon, right, with the given vertices that are 2 4 4 6 and 6 1. That means this one, right? So if I right now, okay, right? So this is my 4 1. Okay, this vertices 4 1, right? So this is 2 4, first one, okay, a 2 4, right? And b, and this vertices is my b 4 6. Correct, either two right, either one, either one, no, 4. Okay, x-axis 4, y-axis 1. So 4 1, this is 2 4, right? And this is 4 6, right? So what is the first thing that we will do here is, right? The first thing that we will be doing here is the first step. See this problem, it has been given in it has been uploaded to your what is it, Google Classroom, okay, right? Fine. So Google Classroom only, right? For module 2, I have given a part with I have given, I have uploaded a document, module 2 theory part. In that, the last question is this problem. Fine, right? So what is the first thing that I will do is, anyway, right? I have clearly said that how your scanline algorithm will process. Your scanline algorithm will process from bottom up. Okay, andre starting from y to minimum to y maximum, right? So in that regard, what is the first thing is, right? The first thing is I will sort all my vertices, right? So based on the ascending order of the y axis, okay, right? So that means, so y is equal to 1, which is minimum, which is my point C, that will be my first point. Next, y is equal to 4, which is the second minimum, so that will be my second point. And next, y is equal to 6, which is the highest y coordinate value, right? So that will be the last one, okay, right? So now see the next second point, which is a very important point, okay, right? So the second point tells, write down the active edge table. Now I'm writing the active edge table. That means my data structure active edge table, how actually it will be stored. That is what I'm showing now, right? So write down the active edge table for each vertices, okay, from ymin to ymax, okay, right? Write down the active edge table for each vertices, okay, from ymin to ymax in the form of array, right? How my active edge table looks like, my active edge table look like an array. This is what my active edge table, right? What they have said, you write the active edge table, okay, for each vertices from y min to y max, right? So each vertices from y min to y max means, right? So from y min means my first vertices is at y is equal to 1, that is my c vertices. My second vertices is at y is equal to 4, that is my a vertices. And my third vertices at y is equal to 6, that is my B vertices. So I will fill those vertices in my active edge table, right? So I have taken the active edge table like this because y it has started from 1 up to 6. So y is 1, 2, 3, 4, 5, 6, right? So now y is equal to 1. So for y is equal to 1, right, I have C vertices, right? So I have written C, fine. So next, at y is equal to 4, I have A vertices, correct? At y is equal to 4, right? I have my vertices A. I have written vertices A. At y is equal to 6, I have my vertices B. This is how I have written. This is how I have written. All other this array spaces, right? This has been left blank because at this y values, right? I don't have any vertices. Okay. From ymin to ymax in the form of array, where each array consists of linked list of edges. Okay, right? This is the next thing that I need to do for my each array block, right? Each array, right, where it consists of linked list of edges, which is of the form ymax, xmin, 1 by m. You know why this 1 by m? Because for calculating the next x intersection point, right, it is previous intersection points plus 1 divided by m. So I am storing this 1 divided by m next to y max and x min. Fine, right? So let me come to each of the array, right? So let me come to this C. Okay, let me come to this C vertices, right? So from C vertices, which are the two edges that are going from C vertices? See, from this C vertices, 1 minute. Okay, from this C vertices, two edges are CB and CA. Correct? Two vertices are CA and CB. Fine, right? Which are the two vertices? It is CA and CB. Okay, right? So it is CA and CB. So let me take the linked list for first edge, that is CA. Okay, CA, right? So now CA, for that linked list, what should be the linked list type, right? So the linked list type, what are the contents of the linked list? The contents of the linked list is y max, that is what they have given, right? What are the contents of the linked list? Y max, x min, and 1 by m. Okay, right? So now let us fill the first box. Okay, CA, right? So CA edge means it is CA, correct? Allah? Okay, it is this point C A. In this C vertices and A vertices, right? So what, which is the highest value of y? See, for the C vertices the value of y is 1, right? And for this A vertices value of y is 4. So which is the highest y value? That is y max, right? So y max is 4. So the first column y max is 4. Okay, next column y min. Okay, right? So whenever I talk about y min, it is not like y max. Okay, where I will choose the highest value of y, right? So y min means, right, the x value, okay, right, of the coordinate, right, for which y is minimum. Okay, it is not x min value. Okay, it is not x min value, it is the value of x, right, for the coordinate for which y is minimum. Keep this in mind. Okay, right, it is the value of x, right, for the coordinate in which the value of y is minimum. Okay, right. Now what is my edge? My edge is CA. I'm talking about my edge CA, right? In this CA edge, right? So which vertices has y minimum? This C vertices has y minimum. Alva, right? This C vertices has y is equal to 1. This A vertices has y is equal to 2. Right? So this C vertices has y is y minimum, that is 1. Right? So now I need to consider the x value of this. Okay, so I have written 4. See, I have not written 2 because from y minimum andre right il 4 ಇದೆ il 2 ಇದೆ, so y minimum is 2 ಅಂತ 2 ಬರ್ದಿಲ್ಲ, right? It is the x value of the coordinate whose y is minimum. Okay na? So y is minimum andre here y minimum is 1, so I need to take c coordinates x value, that is 4. Fine. Next part, 1 by m, right? 1 by m means, right, this is the edge. For this I need to calculate m. What is m? You know, right? What is m? It is y2 minus y1 divided by x2 minus x1. Correct? Right? It's y2 minus y1 divided by x2 minus x1. Right? See, always don't get confused which I need to take x1 y1, which I need to take x2 y2. Always the vertices which is there in this array will be x1 y1. Okay, the other one will be x2 y2. Right? So now based on that, right, it is CA. That means C will be x1 y1 and A will be x2 y2. Okay, right? So now considering that part, okay, see, I have found out x1 y1 value. Okay, see, x1 y1 is 4 1, that is my C, and x2 y2 is 2 comma 4. Correct? Right? So on my x2 value is 2 comma 4, that is my A. Okay, right? So m is y2 minus y1 divided by x2 minus x1, where m value becomes 3 by minus 2. So 1 by m andre minus 2 by 3. That is what I have written here. Okay, right? Now on the same lines we will go to the next edge of which is with respect to C, right? So yes, which is the next edge which is there with respect to C. CA is over, the next edge is CB. Okay, in the CB it is 4 1 and 4 6, right? So y max means maximum value of y. What is the maximum value of y? It is 6. Done, right? 6 I will fill. Next, for x min how do I fill? It is the value of x in which y is minimum, right? So again, y is minimum in my C, it is not in B, because B x value is 6, C x value is 1. So what is y value minimum is in C, so that x value, that means again 4. Right? So now what will be my CB? Yes, it is 6. Maximum y value is 6. Right? So the minimum x value is nothing but, right? So the coordinate in the x coordinate, right? The x axis of the coordinate in which y value is minimum. Right? So that is 4. That means again C only. Right? And we'll come to finding my slope. Right? My slope 1 by m. First we'll find m. That is x1 y1 is again 4 1. X1 y1 is always this first the vertex which we have given in array. Okay, sorted the active edge array. Fine. So x2 y2 is the other one 4 6, right? So y2 minus y1 divided by x2 minus x1, that becomes 0. So m 0 adre 1 by m 0 ne. So 1 by m is 0. Right? Next I will go to the next vertex, right? My next vertex is 4, right? So my next vertex is at 4, that means, right? So when I consider this A vertex, right? So A vertex also has two edges, AC, right? This AC we have already found out with CA, C vertex game, right? So we will not consider this AC. I will consider the new edge, that is my AB. Okay, right? Where A is x1 y1, B is x2 y2. Right? So now for that y max means, right, which is the highest y value, it is 6. So I will write 6. Right? So now coming to y min means I need to find in which vertex, right? Sorry, x min means I need to find in which vertex y is minimum. So A is the vertex where y is minimum, right? That x value on, right, it is 2. Right? So it is 6 2. Yes, it is 6. Y max is 6. X min is 2. And coming to my slope, it is x1 y1 is 2 4, right? That means this A is x1 y1 and x2 y2 is 4 6. When I calculate m, I will get 1. Right? So 1 by m means it is 1 by 1, which is nothing but 1 only. Fine. So my next vertex is B. I will go for B. Okay, right. When I go for B, right, I have two edges with respect to B. One is BA. which I have already found out in the terms of AB. So next edge is BC, which I have already found out in terms of CB, right? So I have nothing to find new for B. Okay, na? That means this is the complete active edge table with the linked list that is remain that I got. Okay, once I get this linked list, okay, then I will go for finding the intersection edges. And that is my step 3. What I will do in my step 3? In my step 3, okay, I will draw the active edge table from y is equal to 1 to y is equal to 6, and I will note down the intersection points. This is the step where I will be note down in my intersection points, right, of the scan line, that is finding my intersection points of the scan line, right, and the polygon, that is the intersection points will be in the form x comma I, okay, right, where I is the value of y in each node. Okay, I is the value of y in each node. Fine, right? So now let me start checking how it will how it does, right? So where I is equal to y now. Let me come to the first, right? That is the same thing, right? Where y is equal to 1 2 3 4 5 6 was there, right? Same thing I will change to I is equal to 1 2 3 4 5 6. Okay, right? So now first for I is equal to 1, for I is equal to 1, that means I is equal to 1 means that is my C vertex, right? So I will take this part. Okay, right? At I is equal to 1, that is my C part. Okay, this part, right? So now I will find the intersection points. See how my intersection points will be is, right? My intersection points will be in the form xi, where I is equal to value of y. So I will get one intersection point here. I will get another intersection point here. Right? So the value of y is equal to value of y. So y value I will get it. It is 1 comma 1. Correct? Huh? Right? Now what is x value? Okay. Right? So now what is x value? Right? See, this is y max. Okay. This is x parameter, x min. Right? So on the same lines here also, this is y max, that is y parameter, and this is x parameter, right? So what is your x? X is 4, here also x is 4. So which are the two intersection points that I am getting? It is 4 comma 1 and it is 4 comma 1. These are the two intersection points that I get. Okay, 4 comma 1 and 4 comma 1. Fine. So how it is in the form x comma I. X comma I means, right, I is nothing but the value of y. So y value I will write it down. It is 1 and 1 because if this is the value. Okay, right. Now I need to find the value of x, right? So if in this linked list, right, which parameter is giving the value of x? It is the second one, because the first one is y max, second one is x min, right? So first one is y max, second one is x min. So x parameter is the second one, so it is 4 comma 1 and 4 comma 1, right? Let us see which is this point. Okay, that means it is 4 comma 1 and 4 comma 1. 4 comma 1 4 comma 1 andre this is the point, below point. Okay, only one 4 comma 1 4 comma 1 both are same, right? So there is no intermediate points. This is the first 4 comma 1 4 comma 1. So there's no intermediate points to be found out, right? So next I will go for the second y value, second this is one scan line. Yes, I got this scan line. So next I will go for this second scan line. Okay, second scan line means it is I is equal to 2. Okay, now that is y value is become for y value 2, right? So now yes, see for y value, see for y value 2, do I have any input? I don't have any vertex, right, for y value 2, right? So for the y values for which I don't have any linked list, right, I will continue with the older one only. Okay, right, that means the linked list for which I had for C, I will take the same linked list for the next y is equal to 2 also, but with a minor change I will do. Okay, right, so let us see what is the change that I will do. Right, I will copy the same linked list. Okay, right, so what is the minor change that I will be doing is, right, see now, yes, it was 4, right, also what was my value here, right, so in my previous, that is I is equal to 1, it was 4. Okay, right, so this was minus 2 by 3 only, this was minus 2 by 3, and this was also 4. ಕರೆಕ್ಟಾ ಎಕ್ಸ್ ವ್ಯಾಲ್ಯೂ, ರೈಟ್, ಸೊ ಇಲ್ಲೂ ಏನಿತ್ತು ನನಗೆ ಪ್ರೀವಿಯಸ್ 6 ಇತ್ತು, 4 ಇತ್ತು, 0 ಇತ್ತು, ರೈಟ್. So now for I is equal to 2, andre y is equal to 2, I didn't had any linked list, so the one which was there for I is equal to 1, same thing I copied here. Only change is, yes, y remains the same thing, right. So what will be my next x value, what we discussed, xk plus 1, right, what is xk plus 1, xk plus 1 is nothing but it is xk, okay, xk plus 1 by m alva, plus 1 by m alva, right, that is what I am replacing for my new x. Y 1 increment agade, that is what we said, that is here it is, that is here it is. Now, previously y was 1, now it is y is 2. See here, y value is 2. Okay, previously it was 1, that means first scan line, now it has come to the second scan line, so y is 2, right, but what will be my x, new x value, new x value is old x value plus 1 by m. So what is my old x value, my old x value is 4, okay, plus 1 by m, 1 by m is minus 2 by, that is minus 2 by 3, that means 4 minus 2 by 3. Okay, 4 minus 2 by 3, and if I multiply here, 12 minus 2 by 3, that becomes 10 by 3. Right, so that is this 10 by 3. That is the change that we will make whenever we don't have any next array linked list. Right, we will copy the same previous linked list. Only change that will be, that we will make is with respect to x. Right, I will change the value of x. So now x becomes 10 by 3 and slope remains same thing, minus 2 by 3. Now for the previous was 640. Now yes, y value I will not change, I will keep the as it is, right. So now x value I have to change, right. What is the new x value? It is old x value, right, plus my 1 by m, right. That means here also it is 4, right, plus what is my 1 by m? My 1 by m is 0, right, that will result in 4 only. So you have written as 4 only. Okay, na, right. So from the new linked list, which are the new vertices, right, the new vertices are, right, so y value is 2 and 2, because I is equal to 2 andre y value are 2 2, right. What is my x value? My x value is 10 by 3 and my x value is 4. So which are the next intersection points? It is 10 by 3 comma 2, 4 comma 2. Andre 10 by 3 comma 2 andre ಎಷ್ಟು ಬರುತ್ತೆ, 3 point something andre 3 point something ಇಲ್ಲಿದೆ. This is 10 by 3 comma 2, this here it is 10 by 3 comma 2, and this is 4 comma 2, 4 comma 2 andre ಇದು 2 andre ಇಲ್ಲಿ ಬರುತ್ತೆ. This is the next intersection point andre second scan line ಗೆ, right, this is the intersection point. Now next y is equal to 3 scan line ಹುಡುಕೋಣ, where I will get the intersection point ಅಂತ, right. So now for y is equal to 3, do I have any linked list with that, attached with that, so that to take it? See for y is equal to 3 also I don't have any special linked list, right. So what I will do, whatever we had for I is equal to 2, the same thing I will carry for I is equal to 3 with the change in x, right. So I is equal to 3, right. So now whenever I is equal to 3 means, right, again this is 4 will remain as it is. Now this x value I have to change, where x, previous x plus 2 by 3, that is 10 by 3 minus 2 by 3, that becomes 8 by 3, that is my new x value, right, and slope remains as it is, minus 2 by 3. Then here also the same thing will retain 6, right? So previous andre 4 plus 0, it is 4 only, and my slope is 0. Fine. So next I will go for I is equal to 4. I will check, is there any node for I is equal to 4? Oh yes, I have a node for I is equal to 4, that is 6 2 1. Right? So now what I will do whenever I have a new node, right? So what I will do is I will retain the previous nodes and I will add this. I will add this new node to that. Okay, andre nange y is equal to 3 nalli enen nodes itto linked list itto, I will retain that same for I is equal to 4. Along with that I will add this new node which is there for I is equal to 4. Fine. So now whenever I do that, what happens, right? So this is the new node 621, this is there, right? So next previous node inda ee node ಗೆ ಬರ್ತಾ ಇದೀನಿ ಅಂದ್ರೆ, right, 8/3 minus 2/3. Okay, 4 ಹಂಗೆ ಇರುತ್ತೆ. X value ಏನಾಗುತ್ತೆ, 8/3 minus 2/3 ಅಂದ್ರೆ 6/3, that means it is 2. Okay, and this is minus 2/3 only. Wrongly I have written like that. Okay, this is minus 2/3. Okay, this I have retained as it is. Okay, right? So now this also I have retained as it is 640. That means 6 6 irutte. 4 ge new value of x beku andre old value of x plus slope andre 4 plus 0 andre 4 barutte, right? And it is 0. Next new node I have got 621. Fine, right? So now in that case, okay, right? So now in that particular case, now I have 3 nodes, right? See, now for each node I was getting 1 vertex, right? Now 3 nodes ide andre now I will get 3 vertex, right? Now when I get 3 vertex, right, I cannot make a pair. For making a pair I should have 2 vertex or 4 vertex or 6 vertex, like this, even number of vertexes, right? But when it is 3 vertex, I cannot make a pair, right? So what I will do, I have to forcibly delete one node, right? So now which node I will delete is, I will delete the node for which the value of this I will be equal to value of the y. Okay, see, this is y, this is x, this is 1/m, leave it, this is y, this is x, ಅಂದ್ರೆ y max x min, this is also y max x min. So here also it is y max x min, right? So now I is equal to 4, right? So which has the same value for y? See, this has 6, which is not equal to 4. When I come to this, okay, this is 4, which is equal to 4. So what I will do, I will delete this node. Okay, I will not consider this node. That is what they have said. As 3 nodes cannot make an edge, cancel the node whose y value is equal to I value. Hence, I am deleting the second node. So which are the 2 nodes that will remain for me? Now this is the one node and this is the another node that will remain for me. So in this, right, I is equal to 4 andre y4. Okay, now value of x is 2, so this is 2 4. Next this is 4 4 4. Okay, now let me check with the next one. Okay, I is equal to 4 ಆಯ್ತು. Now I is equal to 5. I is equal to 5 ಏನಾದರೂ ಹೊಸ ಲಿಂಕ್ ನೋಡಿದ್ಯಾ? ಇಲ್ಲ, 5 ಏನು ಇಲ್ಲ, 6 ಗೂ ಏನು ಇಲ್ಲ, right? So the same thing which was there for 4, I will just retain it, right, with the x value change, right? So for 5 I will retain the same thing, x ಆಗಿ ಇರುತ್ತೆ, y ಆಗಿ ಬರುತ್ತೆ, right? So next ಇಲ್ಲಿ new x ಏನಾಗುತ್ತೆ, it is old x plus 1/m, ಅಂದ್ರೆ that is 1/m. That means old x plus 1/m andre 2 plus 1, so it becomes 3. Okay, right? So slope I will retain as it is. For this node, okay, ಈ node cancel ಆಗಿದೆ ಅಲ್ಲ, right? So ಈ ಕಡೆ ಇನ್ನೊಂದು node ಇರೋದು, this node. Okay, 6 4 0. So the same thing will retain 6. 4 plus 0 is 4 only, so new x is 4 only, 0. So I is equal to 5 andre y value 5 irutte. Fine. So now x is 3 ide, so 3 5 illi 4 5 is my next intersection points. Coming to the next intersection points, right? So illi 6 6 age uliyutte. For I is equal to 6 ಅಲ್ಲಿ ಏನು ಹೊಸ ನೋಡ್ ಇಲ್ವಲ್ಲ, right? So I is equal to 6 age it will retain. So next x value, it is old x plus 1/m, 3 plus 1, it is 4. Slope remains as it is. Next 6 4 0 it will retain, as it is, right? So what will be the next x, right? It is 4 comma 6 and 4 comma 6. 6 is the value of y, so y value remains 6 and 6. And what is the value of x? It is 4, so it is 4 comma 4. Next here also it is 4 comma, right? So now let us check how my intersection points are there. See, this is the first intersection point which we got. What are the things that I told from the starting, right? So my scan line is bottom up approach. Okay, so which was the first one that we found out? This was the first one that we found out. Correct? 4 comma 1, 4 comma 1 to bantu, right? So next ಇದು ಬಂತು, ಇವೆರಡು ಪಾಯಿಂಟ್ಸ್ ಬಂತು. 10/3 comma 2 ಮತ್ತೆ ಇದು 4 comma 2 ಬಂತು. ನೆಕ್ಸ್ಟ್ ಇದು ಬಂತು 8/3 ಮತ್ತೆ 4 comma 3 ಬಂತು. ನೆಕ್ಸ್ಟ್ ಇದು ಬಂತು, ಓಕೆ 2 comma 4 4 comma 4 ಬಂತು. ಸೊ ನೆಕ್ಸ್ಟ್ ಇದು ಬಂತು ನನಗೆ, ರೈಟ್? ಸೊ 4 comma 5, ರೈಟ್, ಅಂಡ್ 2 comma 5 ಬಂತು. ಆಮೇಲಿಂದ ಇವಾಗ ಯಾವ್ದು ಬಂತು? 4 comma 6 4 comma 6 ಬಂತು. So this is how intersection points will be found out. Once intersection points are found out, all the next work is easy, right? So this particular problem is there in the module 2 theory part document which I have sent. Go through that, right? So once, twice or thrice, right, you will understand the things. Any confusion, you call me, right? So I will resolve your doubts. And this is a very important question, 10 to 12 marks question they will ask you in the examination, right? And based on that, this is your assignment. The same thing, find the active edge table for the objects formed by joining the points, 4 points. And this is not a triangle, this is something a quadrilateral that you will get. For that you have to do the same process, right? The process is there in the, we have uploaded in the Google Classroom. Kindly go through the process, right, and finish up finding the intersection points, right? Okay, Lavanya.